Okay, well, how do we deal with kites and rhombuses? Oh man, they both have the same formulas. And I'm not going to prove the formulas. What I'm going to do is I'm going to show you what the formulas are. Then we're going to try one from homework and we're going to see, how complicated things can get. All right. So a rhombus is really just a parallelogram. So if you were to take this shape, let's say I took the shape and I rotated it back around so that it looks just like a parallelogram. Well, if you knew the base down here and you knew the height going this way, you could apply this formula right back here. So maybe what I'll do here is I'm going to put down for the rhombus because it is really just a parallelogram. Remember, a rhombus is a parallelogram of four equal sides. In a bubble here, I'm going to put down the area is base times height because it is a parallelogram. But it also has this other formula that comes into play. Dang it, man! This program I hate when I clutter it up here, and I can't really easily erase. So that's because it is a parallelogram. But there's this other formula. So let's take this and let's rotate this guy back to. This is the way you usually see a rhombus like this for some reason. They don't put it like in the same orientation quite often that they put a parallelogram. But what I want you to do is just so that we know this is a rhombus, let's mark all four sides equal. And then let's draw in some diagonals. So the diagonals are not equal to each other, but they do bisect each other perpendicularly. Now, I said I wasn't going to prove this, but it does kind of, if you would imagine using a formula for a triangle and you did 1/2 base times height, well, there's four triangles in here, and we could show that all four triangles are congruent to each other. And what it really comes out to be is the formula for the whole area is 1/2 the diagonals multiplied together. Because the diagonals are not the same length, we number them like we numbered the bases up here with subscripts. So I put base sub 1 and base sub 2. That's what I'm calling like diagonal 1 and diagonal 2. That's what the diagonals stand for. Okay, so that's what the D stand for right here is the diagonal. So let's make a little note of that. Those are the diagonals that you need to find the lengths of. Okay, and because we have a right angle in there, you're going to use Pythagorean theorem or sine, cosine, tangent or 30, 60, 90, 45, 45, 90 rules. This is a lot of review of those concepts. So if you feel like, oh my gosh, I can't remember any of that stuff, ask your neighbor, ask me for some help. Let's work together. Don't try to short cut the work that might be required in that review process because our brains need to review these concepts. It's really easy just to dump that information. That's what our brains are really good at. So the formula is the same for a kite. So let's draw the two diagonals in. All right, so there's one diagonal. Here's the other diagonal. The diagonals are not the same length, just like they're not the same length in the rhombus, but they are perpendicular to each other. That's why we get the same formula right over here, 1/2 diagonal 1 times diagonal 2. Now I'm going to try a problem with you, and we'll see how things go. All right, so they give us on like 8, 9, 10, 11, and 12. They give us pretty much all the information we need. They're not asking us to do Pythagorean theorem on any of these. We're going to do some more of that tomorrow. But let's try number 12 together. Okay, our last homework problem. So I see what looks like a rhombus to me. How do I know this shape is a rhombus? Let's investigate some of the given information here. Well, it says the diagonal here is being bisected by the diagonal here because they have these little tick marks like this. Okay, that's what a rhombus does. It'll bisect the diagonals. In a kite, this part here is going to be shorter than this part down here. Now this piece here is going to be equal to that one. So one diagonal gets bisected, but not both the diagonals. So since both diagonals are getting bisected, this thing's a rhombus. And it tells me like a little arrow right here. It says this piece is 8 long. All right. Well, that would mean this piece down here is 8 long also because they're equal to each other. They got those little tick marks. And then it gives us this little diagram. It says 17, and it's got an arrow drawn to here and an arrow drawn to here. Okay, so it's like architectural style labeling of lengths. Now they have them in inches, so we got to pay attention to that also. This is in inches. This is in inches. Okay, so one diagonal for sure is 17. Let me just label it diagonal 1. I'm going to call it 17. Doesn't matter if I call it diagonal 1 or diagonal 2 inches. And then diagonal 2 is going to be 16 inches because this is 8, this is 8, right? And so now my area comes out to be 1/2 16 times 17. All right, so half of 16 is 8. So I go 8 times 17. You could just plug all this into Desmos, right? And this is inches right here, and this is inches over here. So another reason why we get inches squared, because inches times inches is going to give me square inches. And then 8 times 10 would be 80. 8 times 7 would be, what, 56? So 80 and 56 makes 136. Boy, I hope I did that right. 136. Please check me on Desmos. Hey, thanks for watching my videos today. I hope that's helping. I hope you see the formulas that we're going to be using today, and I hope you don't struggle too much with the homework. Hey, welcome back. I'm glad you're back from the break.